Okay, let's get started. We're so glad to have you with us for today's webinar, OT Cybersecurity for IT Professionals. Again, my name is Ellie Proudler, PMM of Global Services here at Dragos. We have just a couple of housekeeping items to cover before we jump in. I do want to mention that today's session is being recorded, and we'll be sharing out the recording via email to all the registrants and attendees after the webinar. And also, you'll notice that your microphones have been muted, but we still want you to interact with us. So please feel free to use the Q&A chat feature to submit any questions that you have, and we'll be sure to get to them at the end. And now I'd like to introduce today's presenter, Mike Hoffman, Principal Industrial Consultant here at Dragos. Mike, we're so excited to have you today. Take it away.
Thank you, Ellie. And before I get started here, I do want to just thank the staff at Dragos, Ellie and others for setting up this webinar and for helping out with just the mechanics of it. It takes a team, it takes an effort to do this. A lot of work goes on behind the scenes to produce this content, and I'm really grateful for those working behind the scenes in it. Well, once again, welcome, and wherever you're at around the globe, good morning, good afternoon, good evening. I hope you have your favorite beverage with you and are able to sit back and take note of the things that we'll be talking about today. And this important topic, when we think about OT security in the eyes of an IT security personnel. I wrote this deck from that mindset of the folks who have been tapped. You may have, be in that CISO role, the CIO role, or you may have some sort of a support role from an IT perspective, and you're wanting to glean a little bit more information from that OT side. If that's you, you're absolutely in the right place. For those folks from the OT side coming in, more than welcome. There will be a lot of things that I'll talk a lot about during the presentation that absolutely applies. And so we can definitely, a lot of good material in here for you as well. So with that, let's get started here. So a little bit about myself. So I have around 20-some years of experience, predominantly in oil and gas. My background really started back when I was doing, instrumentation control systems as a technician, coming up through and doing analytical systems, leading into automation, SCADA systems, DCS systems, and that kind of stuff, working across downstream, midstream, and upstream organizations within oil and gas. Now I've been with Dragos for a year and a half as a principal industrial consultant. So a lot of what I do is do a lot of architecture reviews and tabletops, and also work with customers and their efforts and the journey along the way as they try to implement better security controls. On the side, I also teach with SANS and their ICS 612 course. So excited about doing that and helping the community out more from that perspective. And so let's get into really the meat of the subject. And that's really the difference between OT and IT. And, I would like to take this back off into, we're still back in talking about people, process, and technology. And a lot of people will talk about to say that, hey, convergence is going on. So, IT, OT, it's convergence. I'd like to say that it's mostly occurred already. So if you're having those discussions about convergence, convergence is gone. I mean, it's here and it's been going on. The minute we put a Windows operating system within our industrial control systems, convergence was taking place. That's been 20 years ago now. So we've been through this different journey of convergence, if you will. Some industries are way more converged than others, and others are for rightfully so, nuclear sector per se, are very much isolated still within when you think about interconnectivity. But a lot of times folks, when they have this background, they begin to thinking about from an IT perspective, can we apply those same IT controls in an OT? And so that's a common question I get. Well, since we are running this similar type of equipment, can't I use those same controls? Also, what controls should I be focusing on after that first question is asked? And so really, what are the things that should I be tasking with? Should I take my same playbook for IT and apply it to OT? And the answer might not be so. It needs to be tailored, and we'll be talking about that a little bit more. And then it's also always where to begin. Where to begin with our journey? What are the key things that I myself and my company need to be focusing on? And so that is what we'll be kind of talking about here. Now we have a challenge. Oftentimes, and so I've got a graphic up here. Think about though, if you in your sites, if you close your eyes and think about walking into one of your control rooms. I've been on a lot of tours with folks from the IT side when we go into control rooms or those shelters and that kind of stuff where we have a lot of this equipment in place. The question as often first comes to mind, and you hear it, you kind of hear this discussion going on, is that, hey, this control room, this panel, this operator interface looks a lot like IT. It's running Windows. I recognize those applications. So there's always this question about that's kind of an IT asset. And so again, running Windows. But a lot of times the next thing that pops up is, well, wow, it's running an older OS. I see Windows XP around here. Windows 7, that's not good. We need to do something about it. So then the conversation goes that we kind of need, are we patching it? Are we running vulnerability scans on this machine? Are we, because we're so far behind, wow, we need to, put this on an upgrade list. We have to upgrade it. And then finally, and I think the most important question is how critical is this, by the way? So if this machine gets compromised or if we rip and replace, can we do it? And how critical is it to the process environment? And so again, a lot of times the focus is on that IT-ish, I should say, asset only. But there's some problems when we think about computers as computers in themselves, and we don't think about the complexity and the interconnectivity we have with the rest of the OT environment. And so in my job, here are some of the downfalls that I've seen on taking too much of an IT approach. And so some of the mistakes that I've seen is way too much emphasis on vulnerability management, where just so much focus goes into trying to make sure our systems are patched, trying to make sure we have all the vulnerabilities fixed out there. And I'll talk a little bit more about this, is some of the problems with over focusing on vulnerabilities. But that is definitely an issue that I see. And it's because on the IT side of the house, this is something that it's not easy. Vulnerability management is always hard, but it's something that is people can get their arms around. We can put our scanners in place, we can put automatic patching in place, automatic rebooting and all those kind of things, push out new updates in the IT side, and we have the tools in place, the capabilities, the knowledge. We're good at this. On the OT side of the house, we can't do this in many times and in many ways. Our systems can't be rebooted. Our systems may have to stay at a certain patch level for a while. Could be some conflicts. I think a decom is just a patch that Microsoft just came out with decom that breaks decom settings, that can break OPC communication. Going in the weeds here really quick, but those are some of the things we have to think about a little bit more on the OT side of this patching situation. There's also the issue of expecting OT environments to keep pace with IT environments for asset refresh. So when you do see that Windows 7 HMI or HMIs, if you will, in your control room, you may be thinking about, when can we lift that over to Windows 10/Windows 11? The answer may be it is going to take a while because our OSs and the OT side are very much tied to the underlying control system. May it be a distributed control system or a SCADA system, supervisory control and data acquisition, something like that. We also, there's a lot of focus on the business side, on the enterprise side, on moving to the cloud. And I'll say on that side, it makes complete sense. On the OT side, most of the environments I go into today have some sort of a cloud connectivity. So cloud is making its way into the OT environments, and it's not all bad. There are definitely instances where cloud absolutely makes sense, but we have to be very, very careful about how we deploy cloud, that where those connections go from cloud, how far down do they go in the layers of OT? Are they going to an edge where we have controls in place, we have some sort of an edge computer that's doing protocol transmission or manipulation, that kind of stuff, going from an OT protocol to a more IT protocol at that point. We have encryption going on there, or are we trying to do cloud connectivity all the way down to that endpoint device, that remote terminal unit, that PLC? That's where the problem comes in with cloud connectivity. And that's where we have to be very, very careful about our cloud architectures. So this push to the cloud and those kind of things, it can be a problem. There's also an issue around ownership and accountability around, a lot of times you come into a place and you think about something from, we have to get, so if somebody from an IT has been tasked with securing these environments, and maybe, I have been given a responsibility to upgrade these systems or make sure they're secure, but who owns these systems? Oftentimes it's the operations manager at that site who actually owns that system. And then you get into it's the engineering team that runs that system. So there's oftentimes an area where this needs to be kind of discussed and understood who owns it, who owns the budget for the system, because oftentimes security will come in and want to put a tool in place, but security is not going to pay for it. So the business pays for it. So you get this issue of ownership and accountability and those kind of things. It needs to be worked out. So even though security may have a good idea to put in place, it's the ownership and all the ultimate accountability is actually relies at that asset manager. So a lot of times too is we take that discussion around what is most important for OT. And one of the things that the conversations I hear at first is, well, it's just the difference between our triangle, our security triangle. And for those who have a CISSP certification, you may be very familiar with triangles. But the discussion is more than just shapes. It's more important than just confidentiality, integrity, and availability, and flipping that around on the OT side. Because within the OT side, it's not just this simple. There are other considerations that we need to be thinking about. And the most important is safety. So we have process safety to be thinking about. So, as far as we have, we may be, we may be at a generation facility or a refinery or water, wastewater, you name that industry, there are safety considerations around keeping that process in place. Also, the equipment has been engineered and designed to run in a certain way. So there are safeguards in place already, but there's also different things we need to think about from an environmental perspective. What happens if, we may be dealing with some fairly toxic substance at our sites. And so that may be, a main priority. And then there's also personal safety, keeping our people safe, making sure that they go home in the same way they came into work. And part of this too, where what is most important when you think of the triangle, availability or integrity, I would say predominantly availability is what we're focused on, and our systems are been engineered for availability to keep them operational 24/7. However, in some environments and even in a process environment, the confidentiality of some of our systems is actually more important than availability or integrity. Think about pharmaceuticals. Think about an area where your favorite soda beverage. The recipe behind that is probably way more invaluable than the actual plant that's operating it, because create another plant, but we can't recreate that PI, that that intelligence that went behind the scenes, all that R&D work. So it really depends upon what industry you're in, which is that determines which one of these factors is more important than the other. But at the end of the day, it's really around that safety aspect. Also, when you think about OT, OT is really where your company is getting its business, its money, it's where that is coming from. And so when we think about it, what are we doing? What is our core mission within our OT systems, our operational technology environments? And they're really around protecting these. So, you may be sitting back and you may be in generating and transmitting distribution of power. So you're supplying power to our homes. You may be in an environment where you're, dealing with energy from producing transportation and refining from an oil and gas background. You may be, working in metals, raw ingredients to food, creating the food that we eat, all these different things, maybe pulp and paper, or you name it. at the core of it are these systems have to, ensure that these OT systems have to ensure that we are continuously delivering these products and delivering these things to our end users. And so when we put security controls on these in these areas, we need to make sure that at the end of the day, we are supporting these deliverables to our company. We're not just doing security for security's sake. We don't just have a hammer looking for a nail to fix a security problem. So let's look a little bit about attributes of OT systems. So OT systems absolutely interact directly with physical. And this is one of the things I really enjoy about being in this space, being in the OT environment, in the ICS space, is because when we think about it, this is where you can change a value on an interface and see the actual physical process move, have some sort of a change to the physical environment. So OT systems, another attribute is you're actually, again, running machines. You're running robots. You're running, large distribution machines and that kind of stuff that are making products. You're running big pumps and compressors and those kind of things. So you actually have, not only are you changing physical process and reading physical process values, you're manipulating machines and that kind of stuff to do such. And with this is we have continuous and batch processing. So continuous processing, which means just something is running all the time, and we're making small changes to that to create the product that we need. Batch processing is where we get, we're dealing with materials, we're putting it together. Think about making cookies at home. You're throwing things into a batch. You're mixing them up, and then you're throwing them in the oven. Think about that at a large scale, and you got a batch process. Think about also these systems have, like I said before, inherent HSSE risks, human safety and environmental type risks that we need to be very, very concerned about. So when we look at the requirements of these systems within the OT space, the requirements are absolutely high uptime. So we need to be thinking about, when I say high uptime, what does that mean? To some people, that may mean, oh, okay, well, these systems need to run months. Think years. One of the refineries where I worked before, some of the process units would run 6 years between turnarounds, where you'd actually shut it down, perform maintenance on it. Other of our units would run a year at a time. In a glass manufacturing environment where I was doing some consultancy not that long ago, they were talking about their silica furnace running up to 15 years between shutting off. And so when we think about these extremely long uptimes of these processes, you have to always have that in consideration around when we're putting security controls and that kind of stuff in place. Some of these critical components cannot be turned off. So therefore, we have redundancy in place. So often our systems are designed for redundancy. And that wasn't designed from a security aspect. That was designed from that availability and uptime consideration. But our systems do have redundancy, which means that some of our systems can be upgraded, rolled over, and you can work around that. But you have to kind of look into your systems to understand what you have as far as redundancy. We also have things around low latency. So when we're thinking about, we're touching real systems, when we're manipulating physical processes, when we're talking about latency here, we're talking about microseconds, milliseconds to microseconds. When you think about robots and you think about placing parts on vehicles as they're running down the assembly line, or fast processes on a conveyor belt where you're making extremely fast decisions on the quality of a product, if it's going to pass or fail, you're getting down into the microsecond type times. So we absolutely have extremely fast latency issues that we have to think about. And so when we think about networking and that kind of stuff, latency is always a concern and something that we always have to think about. Even from a timing perspective, using like a precision time protocol versus a network time protocol because of a latency issue. We also have vendor requirements, and this isn't a dig on vendors at all. Vendors engineer systems to meet these requirements of the customer, to meet requirements of extreme high uptime, extreme redundancy requirements. But with that, they've created an engineered product. So a lot of times when you go into these locations and you see those control rooms and you say, well, are we running the right endpoint protection on them? Or can I put a an EDR tool or a vulnerability type of scanner tool on this? The answer is probably no. Or here is a very tiny list of approved applications. And the reason why is because, again, these systems have been engineered. So the vendor is producing a product that they give, that they back, but it's all been engineered for that. And they've established what applications can run on it, how their networks will operate, and so forth. And so just always keep that in mind when we think about, putting different agents on our systems and so forth. You might not be able to do it. So therefore, you need to pivot and look at what can we do inside the OS, such as like Windows event forwarding to getting logs off our systems and so forth, where we can use inherent capabilities of our OS and that kind of thing. We also have regulations, of course, NERC, TSA, other things that are driving the industries in certain directions that a lot of these processes or a lot of our environments are under. And another conversation that we get into is, oftentimes our systems require context. And especially when we talk about security controls, when we talk about what systems need to be protected and so forth. So a lot of times, you'll provide an asset inventory to someone, and they'll begin to discuss around, do we have this system in like this Windows XP out there? Do we have one of those? We may have identified it, but context matters on how it's used and where it's used. Because at the top, here in the DMZ, the WSUS server that's providing patches, or within the DMZ, may not be completely business critical. We can probably reboot that server at any time we want, the AV server, of course. But as we go down the network, we begin to look at the criticality increases. So that engineering workstation or the automation servers and even the domain controllers down at these levels become more and more critical, until finally we get down to the actual controllers that are interfacing with the process environment. These are the things that are absolutely critical. Now, when you think about criticality, though, what we're really talking about is risk. And so a lot of times when we think about risk, we think about risk from the perspective of, that consequence times the threat and times the vulnerability. And oftentimes we throw in this little variable that's really tricky as well, called likelihood. So I haven't put it in here, but it's something that we think about a lot, is as far as trying to manage the risk. Because why are we doing security? We're doing security to lower risk, because we know that there's a potential consequence out there. We know that there are threats that are increasing. We know that there are vulnerabilities out there. And so what we're trying to do is manage all of this kind of thing and reduce our risk. The thing, though, is that if we just take this little formula or equation that you have in front of you at surface level, it doesn't talk about the entire story. And the reason why is because in these environments, there's something also called disaster risk, and that's where you're actually looking at the hazard. So that's that thing that could go wrong. So that hazard, and then you're looking at the exposure. So how much exposure do I have with this disaster type hazard? And then we look at the vulnerability of what systems can be impacted. But the thing that is kind of different here is the capacity to respond, the capacity within our systems that we have to actually respond to this. So when we look at, this equation really from the industrial perspective, this is a better equation to actually look at it. From industrial cyber risk is really the consequence of something occurring, times the threat, times the vulnerability. But then we have this thing called resiliency of our systems. And that resiliency is what can kind of take us over that spot if there is some sort of a disruption. Also, when you look at this, what are some of the handles, if you will, in your environment you can change? Sometimes the consequence can be engineered out. Sometimes you can be focusing on the vulnerabilities again. Vulnerabilities are always going to be with us. Threats are increasing. So it's trying to remove or decrease the consequence, perhaps engineered it completely out, or it's looking to your systems to understand, do I even have enough resiliency in place? So when we look at this, so like I said before, is the threats. So like in Dragos, we track different threat groups. And so, you have Electrum, the Malloy here, Xenotime, some of our other ones. And of course, there's been a number of them that have recently popped up. And again, we track those from our intelligent groups. And so understanding the threat and understanding what threat actors are doing into our environments really helps us to understand, do the controls that I have in place today, are they sufficient for a lot of these threat actor tactics, techniques, and procedures? But then also the vulnerabilities. There's a lot of vulnerabilities out there. And so here, this one's highlighting Siemens. It's not a dig on Siemens at all. All vendor products have vulnerabilities. And the vulnerabilities, again, are increasing because there's a lot of research community digging into these systems. So we're finding more stuff. And so again, always focusing on just vulnerabilities is not the right perspective. But again, we have resiliency, and that resiliency of how our systems have actually been configured, engineered, what things do we have in place from a mechanical perspective that can actually help us out and safeguard us if there was some sort of a cyber malicious attack. And then of course we have that consequence. And so that consequence is really that thing that if something does occur, what could actually, what effect would that have in our environment? Would it just be a loss of view? Would it be a denial of service? Or would it be a loss of control where we would have to do a hard shutdown in our plant? Or worst case scenario, a manipulation of control where we're locked out of our environments and the adversary is actually taking over. So these are some of the things that you can kind of be thinking about, but it's important to understand that resiliency aspect. So this is where, and this is something that I do a lot when I'm dealing with customers and we're on an engagement, is looking at crown jewel analysis. And this is really understanding what really matters within your environment. And it's understanding those key areas that you have to have operational. And again, this is digging into operations. So when you come from that IT perspective, it's really important to sit down with your operations folks to really understand the security controls we're putting in place. What are we actually safeguarding against? What physical systems out there do we have in place? And what are the systems that are most important? Because again, not all ICS devices are the same. And each one of them may have different levels of process impact. When we do identify those areas, we probably need to be thinking about other mitigative controls to put in place. Or mitigative controls, engineering controls, again, even maybe engineering it out. But going through the CGA process is not something that your IT security folks can do. It's not something that your OT security folks can be doing in a vacuum. This requires the team. This requires folks from operations and so forth to really sit down and understand your process environments. And the outcome is really, again, identifying those key systems. When we think about this is what does a process look like? And I'll first of all, I'll say that you probably have a lot of crown jewels within your environment, probably more than one. So this is a methodology, if you will, that you can take back into your companies, and you can begin to work these processes out. But first of all, what you do is identify the top level systems, and so you're looking at the regions, the demographics, and so forth. You begin to get into the subsystems, where you're looking at the collection of facilities and the environment, and then you get actually down into the critical functions. So what is the areas? This may be utilities, you may be heating and steam and that kind of thing. And then you look at the critical components. What makes up that critical function? Well, it's the components underneath. These may be all your pumps and motors, your actual boilers and those kind of things. And then we get out down into the controllers. These are the devices that are actually, this is that interface from logical into physical. And these are those systems that if they are compromised, attacked, manipulated, can actually cause some sort of a effect to your process environment, your plant floor, your systems. And then we kind of work back up the pyramid, if you will. And once we've identified your crown jewels to say, so now we've identified the things that can actually be impacted, let's work back up this pyramid to understand how the system is interconnected with other systems. We may be able to see that, we have a lot of connectivity around this critical system that we may want to put some more security controls around. We may want to monitor. We may even want to isolate this. This thing has been deemed so critical and important that we actually need to disconnect it. Maybe hook it up with a serial connection. Hate to go backwards in technology, but sometimes it's a requirement because this thing cannot absolutely not be compromised by a routable protocol. So we may actually even have to isolate it with a think about RS-232 and 45. That might need to occur because due to the risk of this system. One example what I want to share here really quick is that I found working again in a refinery environment. I've seen refineries kind of fall on their face, if you will, trip offline a number of times. And one of the things that did it actually was plant error. And you think about that. And so we can take this analogy, though, into any environment that requires instrument error. So instrument error drives control valves. It drives different, those physical systems within the process environment. And so when you think about this, if you think about how you would actually look at this, so control valves need error. So let's talk about the refinery for a really quick. So what is the system? Where does air come from? It's in the boiler house, or whatever you would call that, your utilities area. Then we dig down into that critical function or subfunction. So we begin to identify instrument error. You normally have some sort of a pressure control system. You're also drying your air. So you have dew point, you have dew point analyzers and so forth. And you have systems around your critical function. Your components, well, of course, your compressor. So you probably have a couple different air compressors out there. You have your pressure control station and, of course, your dryers. When we look into your controllers, though, you may have a vibration monitor around that compressor. That vibration monitor probably has shutdown settings on it. So you need to look at, okay, so that thing can actually trip my compressor offline. Normally you have some sort of a DCS system that's controlling all of your pressure controls around your instrument error. You have your dryer PLC. So you have some sort of a drying mechanism to dry your air to get the moisture out of it. And then, of course, your dew point analyzer, which is actually measuring the dryness of that air. So then when we get down into the crown jewels, we begin to say, okay, so what we really need to do is be protecting this vibration monitor. We need to be looking at the interconnections, if you will, of that system. Can somebody remotely get to it, change settings? Look at the PLC. Can somebody get to this PLC from the network? What kind of controls do we have around that? On the DCS system, the analyzer. And we kind of go back up and look at the remote access capabilities. Look at our firewalls, look at those rules. So again, this is just an example of crown jewel analysis, but I think it's a very, very an easy one to kind of walk through. And so you can kind of take this back into your workplace of work and see how this can actually be used in your environment. This is probably one of my favorite slides when I think about security and where do we start. This slide comes from Robin Lee, but it comes out of some material that we produce in Dragos. It's also in the SANS ICS 515 course, but it talks really about the effort of security and where we need to be putting things in place. It is truly the sliding scales of security is where we need to be focusing our efforts within these environments. So we began with architecture, and architecture is really where you get the most bang from your buck, if you will. This is where we are ensuring that our systems are well architected out, and we're also maintaining our systems. I'll be talking about architecture here in a little bit around the actual areas, but then we get into passive defenses. These are systems that can work without the human involved. Think about things such as monitoring tools, your firewalls, and so forth that are all there to passively defense. And then we get into that active defense, and this is where we have people in our environment. They're actually interacting with our environment. These are your analysts, SOC analysts, and those kind of things that are looking through the logs, looking through that network traffic, and getting into those spaces. As you move over into intelligence, your maturity is coming up. This isn't creating your intelligence. This is often consuming the intelligence. Could be from ISACs, could be from Dragos worldview, other areas where you're getting intelligence down, and then actually doing offense. We don't get into offense very much. This is actually hacking back and so forth. Let's not talk about that. Nevertheless, so this is really the focus of where we should be as on the left part of this slide, and where we really need to be focusing our efforts. So with that, focused efforts. So now let's get into some of the discussion around how do we, where do we start? Because the issue of securing OT is big, it's challenging. And so a lot of times I've heard, and I've been in a lot of discussions around, trying to map out, put in all these controls, trying to, align different controls to different frameworks and so forth. And that's all well and good. But a lot of times we tackle this from too much. We try to do too much at once. And security programs are left kind of faltering and failing because we're trying to bite off too much. We're trying to get from crawling to running. And we haven't gone through that kind of getting up and walking slowly, if you will. And one of the things that we've done within Dragos is we began to looking at these, and coming from Rob and others is looking at what are some of the key things that we see within Dragos, and a lot of the things from working with customers and asset owner operators is what are some of the key things that folks need to be doing, and they're 5. And so this isn't your top 20, this isn't your top 88 or whatever number of controls you want to be looking at. This is just 5 basic controls that you need to be starting with. So if you're trying to develop a strategy, look no further than here. We actually do have a little bit of information on this on our website. So if you want to follow along, you can go to this URL, go to Dragos /5 controls, and that will get you to a good visualization of this as well. So definitely recommend you doing that. But before, let's jump in and have a chat about these. Number 1 is developing an incident response plan and building out capabilities. Now, a lot of times when I work with folks, the discussion is around, well, we have an incident response plan. And so the next question is it from the IT side or OT side specifically? And a lot of times it's an IT incident response plan. The problem is, though, is that when we think about OT, our systems are considerably different protocols, different types of, type of analysis that we do, different types of forensics and all that kind of thing. How we respond, how we contain, how we can recover is considerably different than the IT environment. So therefore, we need to create one specifically for OT, again, for all those types of scenarios. And the important thing too is that don't just create a paperweight, and don't just create a document that you've maybe documented out, but you haven't exercised it. Just as we as individuals need to be exercised, we need to get up and do physical things throughout the day to maintain shape, our incident response plan also needs to be exercised. And so this is really around, once you've created it, do internal tabletops, do those types of facilitated type drills and that kind of stuff to make sure that your contact lists and all those kind of things are up to date and you're ready to go if an incident were to occur. I've seen all too often these plans absolutely fall apart because they've never really been exercised. People will put a lot of good information in them, but without, again, exercising them, you don't know if it's up to the challenge or not. Nextly, building that defensible architecture. Now, you may be thinking about, well, you might be saying, Mike, what we really should be doing is starting with our architecture. The problem is, if you're already compromised today, or if your systems, if you can't respond to an incident, you need to be starting there first, because this takes a little bit of time and effort. Creating an incident response plan, creating those capabilities, beginning to develop them out is not an easy task, but it can be done a little bit faster than re-architecting your environment. Nevertheless, though, architecture is another very, very important area. And this is around really, and some of the best architectures I've seen is where you folks truly come in from the IT side and leverage your skills and capabilities. Some of the best conversations I've had is from enterprise work, sitting down with enterprise architects and learning from them, learning tools and capabilities and those kind of things to begin to understand how we can better architect out from our OT side. Nevertheless, so this is where we bring in our traditional capabilities, but we also take into consideration, though, things that we already have in place that are well documented, such as looking at IEC, ISA zones and conduits to properly architect our networks out, create choke points so we can provide monitoring capabilities and so forth, getting jump hosts in place. And ultimately, what we want to do is once we've architected it out, we've secured it down, we know our data flows. We know where our communications are coming into and out of. The next thing to do is, once we've architected our environment out, is implementing network monitoring. One of the things that I found is when I was doing a lot of engineering work and that kind of stuff at one of the plants that I used to work at, is one of the things that would actually keep me up at night is not understanding how my environment actually worked, how my systems communicated back and forth. If there was some sort of an adversarial activity, could I see it? And at the time I couldn't because I didn't have network monitoring in place. And so that's one of the reasons why I'm a huge advocate of trying to get monitoring from a host perspective and also from a network perspective, because you can see all this type of traffic flows, understand critical communications and so forth. Because visibility really helps you, again, to understand that. When you get in, when you begin to sensorize your environments, you begin to see all of these important things going on, and you can actually, if you have multiple plants, many of you on the call today, I'm sure, work in companies that are global. You have sites all over the place. So if you have monitoring capabilities, you can easily pivot from one site to another site to understand, I'm seeing this type of traffic in this environment. Am I seeing this in other locations? Could I be perhaps looking at a multi-site compromise or something like that? You can automate out different tasks and so forth. You can also look at vulnerabilities when you begin to sensorize out your network. And this is where you're looking at vulnerabilities in the lower areas. These are not Windows vulnerabilities. These are those device vulnerabilities. These are things that you may not have known before, but now that you're understanding, you can look at this traffic, you can understand all the rich information coming through your networks. You can begin to leverage those for understanding, what are my systems? What vulnerabilities may I have down in those environments? Also greatly supports incident response and dealing with those kind of things. And also helping to identify network configuration and system errors. One of the huge benefits for implementing monitoring is understanding your system errors and misconfigurations. As I said before in the presentation, a lot of these systems are in the environment for many, many years. And so a lot of these system errors can go undetected for quite a while unless we are looking for them with these type of capabilities. And really seeing is believing. Once you put monitoring in place, you can then begin to see these, we've architected our networks out. Now we can begin to see these communications taking place. You may identify areas within your environment that shouldn't be communicating, but they are. And it's just due to, again, areas where they need to be changed, modified, constrained, and so forth. As I said before, another thing is focused vulnerability remediation. Now, oftentimes in here, had a discussion around, well, so we've identified our most critical assets, so we need to be focusing on those vulnerabilities first. Well, the problem is most adversarial activity comes from the top down, from the corporate end. So what we recommend is prioritizing your vulnerability management around these areas, around your DMZs, around that upper level in your control network. And this is, around, what we're trying to do here is focus on those areas from the top down. And also these systems are predominantly the ones that are easier to do vulnerability management on. They're easier to reboot. They're not as critical down into the process environment as perhaps some of the lower level systems. And if you really want to do vulnerability scanning, these are some of the systems you may consider. I'm not advocating that you should do it. I'm saying that a lot of companies are looking at vulnerability scanning. A first place to do it could be in your DMZ first, and then look at some higher level systems. Again, test before you go. But again, these are some areas that you can be considering it. As we go down in the lower level of our Purdue model, vulnerability goes out the window, or scanning. You should not be scanning your controllers and so forth. But on the upper level systems that are predominantly Windows devices, it's first test, and then absolutely can be something to consider. Establish remote access authentication. One of the things that we see is remote access with no multi-factor authentication. So just making sure that your systems have that capability. So a lot of times you have vendor connections coming in, where they're coming into some sort of a DMZ. But those vendor connections need to have multi-factor authentication on them, because a lot of those connections will go down into your control zone. Also, a lot of your connections remotely are coming from your enterprise side. So just making sure that you're putting multi-factor authentication on those systems for your engineers and your support folks as well. Another really key area. So again, those connections are coming down into critical areas, and adversaries can easily leverage these open areas if you're not using multi-factor. So, and absolutely key areas within that DMZ, have a jump host, be leveraging multi-factor. And this is really, this is that team slide, because coming from that IT perspective, it really, you really need to be working together. Some of the best organizations that I've seen that are doing this are working together. It's forming that cross-functional team with multi-backgrounds from the IT, from the OT security, bringing in folks from operations, bringing in folks from control engineering and so forth, and having those discussions. And also realizing that this is absolutely a journey, and it's not a project. This is not something that you spin up a huge team, put a ton of money into, go fix, wipe your hands of it and walk away. You're in this from the long haul. And so build those relationships, build those trusts, and build those capabilities out, because this is absolutely something that is a continuous process. The way we look at that from a process perspective in Dragos is we look at this from the first thing that we do is when we're dealing with customers and clients is doing an architecture review and doing that crown jewel analysis, understanding the important aspects of that environment. The next thing we do is we get into data hunting and collections and those kind of things. We may at this point actually do maturity type assessments to understand how well your environments are and how well your processes are in place, moving into thinking about working through tabletop exercises and so forth. So once you've understood your environment, you can begin to do tabletops. You may be thinking about doing penetration testing. Well, it's always kind of that cool thing to do. But penetration testing should only be really done after you've done the basics, after you have a fairly good architecture, you've done everything you think is possible. Now let's test it. Let's test that DMZ, that capabilities that we've already built out, that architecture. Let's make sure maybe from a assume breach type of a penetration test that our systems can actually withstand that, or we can actually detect what's going on. That's a great time to do a pen test, and also get into your systems and do a managed threat hunt. At the end of the day, though, yeah, IT/OT is absolutely different. Even though we are utilizing the same types of systems and the higher level of our networks and our environment, it is different because and it really depends on the context and how we're using our IT systems. And so when you think about that, a computer in one location in the environment, again, has a different risk. It has different capabilities of what it's doing. So you really need to understand how that system is being used and where it is used within the environment. Next is to identify your critical systems. A very, very important thing, because you can't protect your systems, and I would say not that you can't. It's hard to put the same types of controls around all of your systems at once. Oftentimes we need to really strategize on what systems require more focus. And doing that CGA process really helps you to do that, and really helps you, come up with mitigative solutions. But before you come up with mitigative solutions, just kind of like the lot of good discussions right now going on with, like the CEC program coming from INL and others, looking at actually ways to engineer the problem out in the first place, so we don't even have to think about cyber. So and at the end of the day, we try to engineer the problem out. If we can't, then we look at mitigative type of such scenarios, such as preventative controls. And if we can't prevent, then we must detect. So we look at detective controls from monitoring your networks and your host systems, your endpoints, your firewalls, and so forth. And finally, we look at respond, mitigated controls around response. How can we respond, our backups and response processes and so forth. Starting with the things that Dragos is kind of recommending around those 5 key controls. This isn't it. This isn't you do this and you're good. This is those great spots to start with. If you don't know where to start in your security journey, start here. 5 things. And you begin to work on those in your security program. And then from there you go on and further mature out your organization. And then finally, kind of want to put it on a high. This is doable. Defense is doable. Protecting our systems is doable. It's hard, but it's absolutely doable. And you have an absolutely important role to play in this. So no matter what your background, if you are doing something if you're working somehow in the OT space, your role is incredibly important. And thank you for what you do, because you're helping to safeguard your companies and ultimately safeguard and provide products and services to civilization. And so it's hard, but it's absolutely doable. Following certain steps, following certain key things, we can absolutely do this. And with that, I'm going to roll into Q&A and see kind of what has come up throughout the course of some of these things. So with that, let me kind of go through here. One of the things that somebody mentioned on the CIS controls and how many you use, CIS controls are great. You can think of, you used to be the top 20, I think it's the top 18 now. Really start here. And as we mentioned, start with the top 5 here with what we talked about. And then on the CIS controls, it's getting into, top 1 and 2, start there, is know your hardware, know that inventory, know your software inventory, understand that, and then begin to use a lot of those controls. Not all of the controls can be used directly within the OT space, but many of them can. But again, as you further mature your organization, you can implement more controls in there as well. So kind of going in through here, another comment was around what matters in the industrial cybersecurity risk. Shouldn't the consequence be divided by resilience as well? Perhaps, but consequence is kind of stands on its own, and so that is all. That is also a good comment. But when we think about it, the consequence is there. So, how from that perspective, will the resiliency of our systems the resiliency of our systems, if we build up that resiliency, it may it'll have a different impact to that as well. And getting down here a little bit more. So another question was around using the CGA. How would you propose to use it for a large site, having compressors, emergency shutdown systems, DCS, HVAC, and so forth? That's a great comment and a great question. As I mentioned before, and CGAs, your site is going to have multiple CGAs. And so what you do is you pick those key critical systems, and you can do this for each one of them. You can do it a lot of times. What I look at is looking at a processing unit, looking at that key recycle compressor maybe, or that compressor on a gas pipeline, or the pump station on that pipeline, if you will, and looking at each one of those systems. And again, this isn't a huge process, but it will require a multidisciplinary team to walk down and to identify each one of those key systems, and then identify the crown jewels of them, and then how they are connected back. One of the things that I will highlight, especially for you folks in manufacturing, The HVAC systems are commonly one of the areas that you want to focus on, because a lot of times, especially when we get into food, when you ask the question of what happens when your chillers go offline, a lot of times the response comes back is where your environment, you'll have to lose not only the product that's in your warehouse, but the product that's on the plant floor. So again, it's that taking that thought process of, a lot of times we're so hyper focused on the actual process, but what about our utility systems? So utility systems are often a good one to look at from a crown jewels perspective, and so forth. Another thing around here is talking about, another question was around, you plan to address zero touch approach. What about SASE? All those things. What that question is really around is that IT architecture around, SASE is one of those new concepts around, cloud connectivity, bringing cloud at the edge, if you will, or distributing cloud around different areas and using, providers, backbones, and so forth to get in. Companies are definitely using that and so forth. So a lot of times when we think about the enterprise side, our networks are kind of going away, and they're moving into the cloud, and we're getting SASE connectivity down to sometimes the plant edge. So that is absolutely there, but still a lot of these systems within the OT environment are still, we can't, a lot of our networks cannot be taken out. They have to be on the plant floor from a high speed, that reliability perspective, and those kind of things. So a lot of times when we think about that cloud connectivity, those are systems that don't have a direct, a lot of times, process impact. We're a lot of times talking about visualization systems, digital twins, and so forth, where we're pumping data out. But a lot of times there's not a direct feedback loop back in and controlling the plant floor or that process environment. So another question is around, let's see, do we need integrated ICS incident response plan with a corporate response plan due to ICS OT converge? Absolutely. So the way this works, and this is one way to look at it, is around within your incident response plans, that IT response plan, again, because of this, heavily converged environments we often see, is there needs to be a very, very strong overlap between the two. But there still needs to be some sort of a separate OT plan, because especially when you think about a response at a site, and what I'm talking about is, think about a response out to a substation or something like that. Your IT response plan is not going to work out there. So we have to have a response plan, but they do have to be married up together. So where there's an overlap, because a lot of times the person who's getting notified it could be a team of, you're from somebody from your IT SOC, where they're getting that initial notification, and then they're calling out to somebody in the OT side to go find out, to go do that initial triage, to begin that process of understanding more about the environment, maybe getting into that containment phase and so forth. So there has to be an overlap and a marry between the two, but you still should have that separate plans, because truly the response is quite a bit different. So it does have to be aligned, but not. Appreciate some of the responses. Again, a lot of awesome questions on here as well. Let's see, kind of going down through here. One of the questions is, how many times do you recommend I do the pen testing? A question. Again, around pen testing, again, I love pen testing. It's a validation of security controls. So how often should you do it? If you do it to where, again, once you've created that architecture, you go back and you test it with a pen test. And then when things change or something like that, you'd want to go reevaluate with that pen test. But it depends on what industry, the risk at that one location. So pen tests probably should be redone in certain industries and certain environments, but it's something that it's a lot of cost and time and effort. So it's kind of it's a risk decision on when you should do it. Definitely, as things change, as you re-architect or add new applications, add new capabilities, those things would actually need to go be retested, and that would be a great time to do that. Let's see, kind of going down. I think we're actually at the top of the hour. So many good questions here, but I think it's probably time to wrap it up. I do thank you so much, though, for kind of sticking with me today with this presentation, and really appreciate, again, all the effort you folks do and how you are supporting your companies and this industry, the OT community as a whole. So I just want to say thank you again so much. Thank you for the team here at Dragos for helping putting this on. And thank you for, again, doing all the excellent work you're doing. With that, hope you have a wonderful day, and I hope you take care. And with that, talk to you later.